On June 2nd and 3rd, 2011, the Center for Design and Geopolitics held its first annual conference in La Jolla at Cal IT2, the California Institute of Telecommunications and Information Technology, on the campus of the University of California at San Diego. So, the topic of this this panel is the agency of code, how that agency works itself as form, as tool, and as policy. Three different kinds of agency. Socrates, the famous Luddite, who we know, of course, we know his Jeremiads against writing because Plato wrote them down. Argued, of course, that writing itself was what he called a pharmakon, the word from which both pharmacy is derived, which means really both cure, both a cure and a poison, both at once. The writing is both of these at once. And the term, I think, has usefulness for beginning for thinking about the way in which code works, and the form of code, the way in which code works as a kind of writing, and the way in which the agency of that code works to write us. We can think of the citizen in the traditional Kantian models of the citizen. The citizen was a political subject that was capable of writing and capable of being written to. So we, as citizens, or as formalized political subjects, embodied that pharmakon as both cure and poison. And during the Roman era, the citizenship, however, was derived largely through your membership in a particular city. You're a member of a jurisdiction, civis Romanus sum. And as we are now, as we know, a majority urban species, more people live in cities than outside of cities, the question of that civis Romanus sum is one in which it's not so much citizen of any one city, but rather perhaps a citizen of a kind of universal city, a kind of aggregate planetary scale city that is, in a way, already both the cosmos and the polis from which any cosmopolitanism might derive. The motto of the open government movement, which we'll hear a little bit about, the digital vision of the open government movement, as in Tim O'Reilly's terms, government as a platform. That governments, which has always been, and Foucault writes about this in a different way, have always been a kind of information gathering and processing mechanism for the production and organization of populations. But that the government is not only information producing and gathering entity, but in the government as a platform model, also a ubiquitous and democratically reprogrammable machine for making the world as information and making it as, in principle, as useful as possible. So in this, self-governance becomes a kind of, depending on which project we're talking about, either perhaps the dream of the cybernetician's dream of infinite leisure, or on the one hand, a sort of infinitely rationalized labor on the other, or in Nicholas Luhmann's terms, a kind of infinitely autopoetic social system. But as our three presenters here today, in their different ways, Casey Reas, Liz Loesch, and Ricardo Dominguez, the idea of governance as code base has a kind of pharmacological quality, that it is both remedy and poison, an ominous promise in a way for both when it works and when it fails, both as a society of control and as a kind of fragile infrastructure, and as, like any form of writing, a means of expression and beauty. So one way to think about this in this convergence is another word that's come up again and again in our discussions is that of the commonwealth. And the ways in which the digitalization of our social systems, our cultural artifacts, and the rest of it has in a way come to make them all but unownable. We think of the price of music in a way. Eric Schmidt, the former CEO of Google, argued at a talk with him that he believes that the ultimate effects of the digitalization of the economy will be one of a transformation of economies from economies of scarcity to economies of abundance, precisely because of this, the way in which digital systems make things not state property, public property, or private property, but essentially unproperty, not ownable. So at that point, a kind of doubling of the pharmacon around this as well, we see a point perhaps where Eric Schmidt and Carl Schmidt line up in ways in which we wouldn't have expected. So our first speaker on this in this constellation is Casey Reas, a dear friend of mine, also former colleague during my time at the Design Media Arts program at UCLA. Casey is known for many things, perhaps most known for his co-authoring, co-invention, co-engineering of processing, a software platform, a software design methodology. And in terms of this genealogy of the pharmacon, we can say that, from voice to text to image, processing has a particularly interesting place, I think, in the history of this, where as images have become increasingly interactive and as interactive systems have become increasingly imagistic, processing as a model for creative reprogrammability, for a model for literacy, really, programmability as the capacity to program as the capacity to write and to speak as literacy within a society of the code that allows people to, in fact, to frame and to structure the agency of the code according to their own terms, is one that has been widely and deservedly appreciated. And in this, Casey is not only the inventor of a language, but also a master of its poetry. His software, prints, installations have been featured in numerous solo and group exhibitions at museums and galleries in the US, in Europe, and Asia. His ongoing process series explores the relationship between naturally evolved systems and those that are synthetic. This imagery evokes transformation, visualizes systems in motion and at rest, equally embracing the qualitative human perception and the quantitative rules that define algorithmic digital culture. Organic form emerges from precise mechanical structures, and I would argue vice versa. He holds a master's degree from MIT in Media Arts and Sciences, as well as a bachelor's degree from the School of Design and Architecture at University of Cincinnati. So with that, it's my real pleasure to introduce my friend Casey Reas.
Thanks very much, Ben. So the big picture for this talk can be summarized fairly briefly. For the last decade, I've been working to encourage more designers, artists, and architects to program computers to code. It's been a very narrow domain. My head's been down most of the time, really focusing on that. I'm now beginning to try and look at it with a little bit more perspective. I think the larger question is, why have I been working towards that? In my opinion, the complexity of our culture and the world requires the type of thinking that programming enables. And by that I mean, we need our designers, artists, and architects to be able to think in terms of models and simulations. They need to be able to think and build systems rather than a set of fixed relationships or objects. They need to be able to grasp, analyze, tackle difficult, complex systems. They need to be able to break them into smaller, manageable pieces in order to understand them. And they need to build relational machines rather than single instances of an object or an idea. So this talk, rather than following a line, is more of a set of topics. It's an unordered list. The first of which is a brief history of coding. So the term real programmer is used to describe the first generation of computer programmers. As described by Eric Raymond in The Cathedral and the Bazaar, quote, "The real programmers typically came out of engineering and physics backgrounds. They were amateur radio hobbyists. They wore white socks and polyester shirts and ties and thick glasses, encoded in machine language and assembler and Fortran and a half a dozen other languages now forgotten." Of course, Fortran's not forgotten. Before the 1960s, there were only a few dozen computers in the world, and they were the size of a large room and required a large staff to maintain them. I think the important point there is that access to these machines was strictly limited. The next rough generation of programmers were the hackers. So hackers are enthusiasts and experts. They're people who are technically adept and love solving problems. Hackers used a new generation of more reliable, less expensive computers such as the PDP-1. They had a less serious and oftentimes subversive attitude towards these computing machines. Hackers invented the first video game, pictured here, Space War, where two ships battle on screen. This is an image from MIT. And hackers are definitely the prototypical alpha geeks. The next category in the story of programmers is the amateur. The widespread coverage of personal computers in the early 1980s allowed for a new and unique group of computer users, amateurs and children. Through languages like BASIC, millions more people learned how to write programs. My generation was the first to learn to program in elementary school, and this led to the next category, which I think is the present. This is the category which I call the hybrid. So a hybrid is a professional in a field who also knows how to program well, but they use it for their work. They're not professional programmers, but for them, programming and computers are a medium to think with and to make work with. And they use these as tools for thought to allow them to do their work. For example, the statistician who makes simulations, the economist who makes agent-based simulations, the person who studies the genome, who uses computation as a way of analyzing their data. And so the rhetorical last category is everyone. Well, there'll be a time when everybody is expected to, or everybody learns to program. In my opinion, this is a really interesting concept. I think the same way that we had a fundamental shift in our culture when a larger group of people learn to read and write, I think the same can happen if more people engage with programming. So the next topic is procedural literacy. It's kind of a hairy term that means something that I think is very graspable and a really important concept. I'm still looking for a better term than this, but at the moment, this is the placeholder. So while I read, I'm going to play this movie. This movie was made in 1965, and it's a film of Frieder Nake, who at that time was a mathematician, making programming drawings. So software is a tool for the mind. While the Industrial Revolution produced tools that augmented the body, such as the steam engine automobile, the information revolution is producing tools that extend the intellect. The software resources and techniques at our disposal allow us to access and process enormous quantities of information. For example, the science of genomics and the collaborative scholarship of Wikipedia are not possible without the aid of software. But using software, of course, is not only about increasing our ability to work with large volumes of information, it also encourages new ways of thinking. The term procedural literacy has been used to define this potential. Michael Mateus describes procedural literacy as, quote, the ability to read and write processes, to engage procedural representations and aesthetics. One component of procedural literacy is the idea that programming is not strictly a technical task. It's an act of communication and a symbolic way of representing the world. A procedural representation is not static. It's a system of rules that define a space for possible forms in action. Ian Bogost defines this in his book Persuasive Games, The Expressive Power of Video Games. So to quote him, to write procedurally, one authors code that enforces rules to generate some kind of representation rather than authoring the representation itself. Procedural systems generate behaviors based on rule-based models. They are machines capable of producing many outcomes, each conforming to the same overall guidelines. And then to quote Marshall McLuhan, related to the emerging media of his time, he wrote, today we're beginning to realize that new media aren't just mechanical gimmicks for creating worlds of illusion, but they are new languages with new and unique powers of expression. So in my opinion, writing code is one gateway to realizing these new forms. Learning to program and to engage the computer more directly through writing code opens the possibility of not only creating tools, but also systems, environments, and entirely new modes of expression. It's here that the computer ceases to be solely a tool and instead becomes a medium. Often, to realize a new or unique vision requires exceeding the limitations of existing software as tools. So to go beyond what the current software does, and you do that by extending it through coding or through writing your own software from scratch. That is the introduction to procedural literacy. So in order to demonstrate what I mean by procedural literacy in relation to the arts, I'm going to show two projects that I've been working on. The first one, Process Compendium, is something I've been working on and off for the last 7 years on. And it is a very general system of behaviors and geometric forms. And through those, I then am able to deal with, generate a series of very organic images from these extremely minimal, simplistic, mechanical definitions. So we start with the first element, which is a circle. The first behavior is move in a straight line. The next behavior is constrain to surface. The third is change direction while touching another element. The fourth is move away from an overlapping element. So if we take these behaviors and we take that piece of geometry, we add them together into what we call element 1. This is what that looks like as a diagram. In order to read this a little bit better, we can reveal the different behaviors. This arrow represents behavior 1, move along a straight line. This one, behavior 2, which is basically when you're touching another one of these circles, you rotate. The next is when you're overlapping another circle, you move away from its center. So when you're working with a basic system like this, of course, you can make different decisions. For example, the speed at which they're moving or the size in which they're moving. And by changing these parameters, the parameters of the system, new forms start to emerge and unfold. So to kind of recap, this is element 1, and this is element 3. So element 3 is different in that it uses a line rather than a circle. And then we've added this behavior of enter from the opposite edge after moving off the surface. This, in a sense, creates a toroidal surface out of the flat two-dimensional screen. So this is that element as a diagram. You can see they move along straight lines, and then when they overlap, they begin turning. Here with another set of assumptions, or changing parameters. Element 5, the difference here is behavior 6 and behavior 7 orient towards the direction of an element that is touching and deviate from the current direction. So this is what that looks like as a diagram. With these simple behaviors, we begin to see this phenomena of flocking happen as they assume the same orientation as their neighbors. So at the moment, the system, this library of forms and behaviors, this is the current status. It's these few simple rules. And from that, I'll show you what comes out of that. So this is what I call a process. And a process essentially is taking many instances of one element, putting them together within a space, and allowing their behaviors to play out and to see what emerges from that. So in this case, process 4 uses element 1. That's the first diagram we saw with the circles. And it has a basic rule that when two circles are touching, you draw a line between their center points. And in this case, the shortest possible line is represented as a black line, the longest possible line is a white line, and then the various grays are the distances in between. And you have shorter or longer lines with the circles are larger or smaller. So here, this is how that's defined. I usually define these processes in English rather than in code so that it's legible to the larger group of people who don't read source code, and also that there's still ambiguity involved. When things become source code, they become so precisely defined that a lot of opportunities or variations become lost. This is another iteration of process 4 where there's a few different assumptions about the system and some of the parameters are changed. So when this one begins, it begins at a state of maximum entropy where there's a random distribution across the screen. And over time, order begins to form as the behaviors are followed. Oops. I just closed the software rather than switching to the next, so I have to go back through. I got so caught up. All right, this is process 10. Process 10 is identical to process 4. But here you see something that's fundamental about the phenomena of emergence, this idea of imposing an order or a structure. So instead of having this random initial distribution, the elements are only able to emerge from a single point on screen. And so it creates a very different kind of visual order and structure through applying this one rule. That's process 10 as the text, which basically just defines what I just paraphrased. And the last one we'll look at is process 18. And process 18 is based on element 5, which is the lines that we saw that were flocking together in the end. And so here, the way it's visualized is by connecting the endpoints of the lines together to make quadrilaterals. And then again, the different gray values we see are based on the initial values of each of the lines. So for me, this has been a large exploration with no real end or no definite outcome. It's been more something that's the energy of my curiosity going into doing this. All right, so that's process 18. So what I want to show you are process 18 through 4, different still images that represent the results of these processes unfolding. So this is, and again, the point is that all of these different organic form languages emerge from that very small subset of forms and behaviors that we saw the list of a few minutes ago. So this is process 18, 17, 16, 15. And then we end at process 4. So the next project I want to introduce to talk about this idea of procedural literacy and working with systems is the Chronograph project. This was a commission for a new Frank Gehry building that opened in Miami last January. And here you can see the building, and then the chronograph is the projection you see on the right. And it's a time-based ambient clock that turns on every day at dusk and then runs until midnight. It was, this building is for the New World Symphony, which is a orchestral academy, almost like a postdoc for musicians before they enter into different symphonies around the country and the world. And the motion of this piece is it's time-based. It gets new energy every second and inspired by a lot of structures in music that we were greatly inspired by. Most significantly, I would say American minimal music and phase shifting and different rhythms in the motion. Here you can see the building in a little bit larger context. There you can see it in precise architectural detail. And so in order to do this project, we took thousands of photographs over the course of the building being built over a span of 2.5 years. And we began assembling them in these collages. And these collages were produced by hand, not by hand, but manually using digital software rather than produced programmatically. And so I'm going to go through and you can see a little bit of the process where we take an image, we crop a piece out, and then through repetition and different transformations, create something new out of that. So basically reimagining the architectural space. So over the course of about a year, we developed over 1,000 different compositions. And then the goal then, the thing that required this kind of literacy, was to take these 1,000 compositions and break them down into a piece of software that was able to display this for 6 hours a day for months on a time without any repetition. And in the end, we narrowed it down to 365 different compositions. We narrowed it down to 12 different motion-based systems. And then from there, produced the software that was capable of these variations. And again, this piece it's not meant to be a piece of cinema that's watched, but it's meant to be an ambient part of the environment of the building and the park next to it. So you can see the kind of motion that's involved here. A little bit of motion, very subtle, very slight. And then every hour on the hour, it shifts to a new composition. Right now I'm going through them rather quickly. And then the areas that are black here are actually the surface of the building. So it's a really different kind of perception. So going from thousands of collages to editing that down to 365 different compositions, and then encoding those in software in a way so that it was able to produce this dynamic part of the building that gets activated in the nighttime. So to do that, we basically have these images that we edit out and then develop this really simple data system using XML file format in order to create all the changes and all the variations. Another image, this one from the construction of the building. Forms that were lost after the building was finalized and covered. And then again, it's changing these values by slight amounts, by tenths, that cause macro changes and really different things to happen on the facade of the building. Here you can see a little bit better. And then this is the projection tower that's running the whole thing. All right, so to talk a little bit about processing, I want to talk about the origins of the project. And I think to do that, I should just show you what processing is, because I know not everybody in the room knows what it is. But the idea of processing is to have a programming environment that we develop specifically for the visual arts, for architects, designers, artists. And the difference here, I think it's a very subtle shift, but I think it is an important shift, is we teach programming through making images, through making animation, through making interactive experiences. The history of programming pedagogy is all done through calculation and making text. And so this shift enables a whole new segment people who think in a radically different way from the traditional computer science thinking to be able to understand these fundamental ideas. So processing was most inspired and developed based on this language called design by numbers, which is the brainchild of John Maeda, who was my advisor at MIT back a decade or so ago. And design by numbers was an amazing system because it allowed designers without any experience to enter and engage with these basic programming concepts of using variables, functions, iteration, etc. But it was constrained to this very small space, which doesn't allow people to realize their full ambitions. The alternative to that are this kind of professional programming environment. And I think you can see really easily the contrast between the two. And so with processing, we set out to make something that was a bit in between, basically a bridge between the two. So with processing, you can write code that's just a few lines long. You have a few menu buttons that allow you to do the basic things you need to do. But at the same time, you can add complexity. For example, here's a slightly more complicated program. And it has 2 tabs. So you can begin to add, in a very modular, scalable way, the complexity of the program to the point where you're actually programming full Java programs entirely within this environment. And then you can actually migrate out of the environment into a full Java editor. So that's the primary idea of the project, was to bridge a web method that was really appropriate for beginners, for beginning artists and visual designers, with what's done in a professional environment, and to meet that halfway. This is the ecology of processing, things that have influenced and things that it has influenced. One of the most exciting new iterations is having the Android mode, where you can actually, just by basically changing this, immediately have programs working on mobile devices without going through a lot of jumping through the hoops that you would on other platforms. All right, so another important thing about processing is that it allows you within this minimal framework to have access to a lot of the power of contemporary computation. So for example, I'll just show you a program for doing face detection, which at one time was a topic of academic research, but now is at a point where within a few lines of code you can have something working. And this really allows designers to enable their ideas without needing semesters of computer programming training. So basically to reduce that barrier for designers exploring their ideas. This is a graph of the number of people who use processing. And I think the important thing about this graph are these patterns that you see. So these valleys are summer holidays, and these valleys are winter holidays. So basically, I think what you can see here is it's heavily, heavily tied to the academic structure. The last thing I want to talk about is the pedagogy behind processing. And again, I think it's this subtle shift which has made a huge difference in bringing programming to design and art schools and those programs inside universities. So in writing a book about programming for designers, we did something that hadn't really been seen before. And that was, in writing the book, it's about 1/3 text, 1/3 code, and 1/3 images. And you have these really concise programs that you can type in, edit, or just load. And then you have the images that are produced there. So we're really trying to keep the design students who are visually motivated engaged, and to give them basically a library of examples that they can collage together and make new programs from. These are the current series of books that use processing. And this is the one at the moment I'm most excited about, which is our O'Reilly Make book, which allows a much lower price point and hobbyists and amateurs to have this basic introduction to programming. And the thing I'm excited about it is this curriculum, which has been organic and developing over the last decade in the classroom. And essentially, it's a way of teaching programming that it's a different order and different methodology than is typically done in a computer science department. And everything's always done within the framework of making images in motion. So you start off by drawing. In there, you learn how to use functions. You learn about the coordinate system. You then move into doing variables. And then immediately, you move into interaction. So using the mouse and the keyboard. And then learn how to load media, photographs, typography, things that visual people care deeply about. And it's then that you get into some of the more interesting math, trigonometry for producing motion. And at that point, you then get into what I think of as the meat of computer science education and understanding, where you learn about how to write your own functions. You learn about how to write your own objects. You learn how to work with many elements through arrays. And once you have the basics, these things flow very naturally. And at that point, students are really motivated to be working with these structures because, in a way, they've been doing it the slightly tedious way of writing things out in a longhand way. And these structures then enable them to make new kinds of structures and explore different kinds of ideas. So I'll end it at that. Thank you very much.